Well, welcome to study for GATE and ESC solution. In this video, we will continue with the remaining GATE question, GATE and ESC solution from 1995 to 2019. I will solve all the previous year GATE question and ESC solution. So it is very easy for to revise and get any PSU or join any IIT or ESC, because in January there is a ESC preliminary is there. If you finish within I will take next 2 months to finish this one, so it will be very helpful for the student to revise this one and take mock test to do more performance. After this one I will solve for ESC preliminary for general study also. So if we continue this one, share, like and subscribe. So we will continue with the remaining problem. So question number 22, the option A, this is one capacitor, A one capacitor, B another capacitor. In A capacitor they have given that in A capacitor the dielectric is air, means epsilon is equal to 1, but in B capacitor they have divided into two parts. So this is one capacitor, this is second capacitor. In capacitor they have divided into two parts, and in B capacitor the area is divided but D is remaining constant. Here they are asking, in this division, one division is air, means it is a dielectric is 1, another division is dielectric constant permittivity of ER is there. So they are divide one capacitor to two way. One is dielectric is air, another is some resistance. So they are asking what is the what is the modification capacitance for this one. So the capacitor divided into two parts, one is in air, another is some resistance here. So if you divide in this way, so area is division, so its area will be A by 2, its area will be A by 2, its dielectric will be epsilon is equal to 1, its dielectric will be some resistance is there. So normally calculation formula for the capacitor in any material is equal to C is equal to epsilon R A by D. So A represent dielectric permittivity of free space. So its value will be 8 into 854 into 10 to the power minus 12 Faraday per meter. A represent the plate area and D represent the distance between two plates. Here this is the D, distance between two plates. A represent the area of this plate. So this is a normal formula for calculation. See, listen, when area is divided in this parallel plate, area division means two parallel plates are in parallel connection. When distance between them is division means it is series connection. So look at in this figure, the area is divided, area is division, so it is in parallel connection. So in parallel connection in capacitor it will be C1 plus C2, because in parallel and resistance both are opposite. That's why here parallel connection C is equal to C1 plus C2. First calculation for C1 from this figure, epsilon, this is D and A by 2. So epsilon, which value will be 1, A by 2 into 1 by D, plus for this one epsilon, which will be normally 1, and epsilon here, this is given for this video, plus A by 2, because area is division here, area is divided by 2, so into 1 by D. So if you take here epsilon naught, in the consider two equation, epsilon naught A by 2 and 1 by D, these all are constant. So if you take outside, we will get epsilon A D, so 1 plus 1 by epsilon ER by 2. So this is the value we are getting, C0 means initial capacitance. So put this one upon this value, epsilon C capacitor, previous capacitor, into, if you take this 1 by 2 outside, epsilon C0 into 1 by 2, if you take this one, 1 plus epsilon R, so is equal to, so the total modified capacitance is equal to C0 by 2 into 1 plus ER. So this is the total capacitance after modify of the both the capacitor. One part is in air, another part is in some resistance epsilon R. So the in question number, the option A is the correct answer. So in question number 23, in this question they have given that two identical means two equal inductor are connected in series, but one series connection we are getting 380 microhenry and another possible we are getting 240 microhenry. They are asking find out the mutual inductance. They are asking the mutual inductance in the capacitor, in the inductor. For inductor, the series connection is two possible. When inductor are connected in series, there is a two possible value. In first case, which is additive in nature. Additive in nature means this is inductor 1 and this is inductor 2. When current flow from here, it is entering dot. Here the enter point also dot. In inductor 2, so enter point also dot. So the current entering in dot also there. In entering also. In L1 the enter also is dot. In L2 the entering also is dot. So it is border dot are the in starting point only, begin starting of the inductor. So it is additive in nature. And listen to and see the figure 2. Listen, whenever current enter here from inductor 1, the in starting of in inductor 1 there is a starting dot is there, but when we come for the inductor 2, it is the ending of the dot. Means see, in figure 1 both the dot are from the starting of the inductor, but in figure 2 one dot will be starting, another dot will be ending. So it is normally called as subtractive in nature. So based upon this one, we will divide a inductor in series connection into two types. One is additive in nature and one is subtractive in nature. So according to dot convention, we will divide in two types. So additive means border dot are the same way, and subtractive nature means border dot will be in different way. Let's see the question. In that question, they have given that both L1, L2 is equal to L, because they have told two identical inductor, they are connected in series. So first consider additive in nature. So L1 plus L2 plus 2M, where M is the mutual inductance. So when we are editing these two, we can write L plus L plus 2M is equal to 380. L plus L minus 2M is equal to 240. So 2L plus 2M is equal to 380. 2L minus 2M is equal to 240. So when we subtract from equation 1 to equation 2 from 1, so we are getting 4M. So minus, these two will be cancelled. So minus into plus. So minus, so 4M is equal to 140. So M is equal to 140 by 4, which is 35. So the mutual inductance in the given figure is 35 microhenry. In question number 24, they have given that this is network 1, this is network 2. They have connected in different way. Means in first way they are connected. This is the first way, this is the first path, this is the second path, this is the third path. So in first path, the resistance between them is 3 ohm and voltage will be 6 volt. In second path, 2 volt, 2 ohm. In third path, 5 volt, this is a voltage source. In this question, they are asking what is the power this voltage source will be delivered. So we will calculate based on the question. So first calculate the individual line current. So here is 6 volt is given, 3 ohm is there. So the current will be 6 by 3 is equal to 2 ampere, and the current will be in resistance. Always the current will flow from positive to negative. So the I1 will be in this direction. Let's consider for line 2. So in the second line voltage will be 2 volt, resistance will be 2 ohm. So the current will be 2 by 2 is equal to 1. I2 is equal to 1 ampere. So in resistance plus or minus, the current will flow in this direction, it is 1 ampere. And for calculation I3, we can apply either in network 1 or network 2, apply the KCL rule. So KCL rule. So for example, take N1 as a KCL formula. So entering here, so taken as negative. This is leaving here, going outside, taken as positive. Suppose this will be considered the I. So I is equal to 0. So minus 2 plus 1 plus I is equal to 0. So I minus 1 plus I is equal to 0. So I is equal to 1 ampere. So I is equal to 1. So I is equal to 1 ampere means the current flowing through this voltage will be 1 ampere, and that is away from the N1. This is I3 is equal to away from N1, which is 1 ampere. So the current flowing through the voltage source will be 1 ampere, and the power at the voltage source, and the power voltage source is 5 volt given. I3 current is 1 ampere, so the power will be V into I. So 5 into 1 the 5 watt. So the power delivered by the voltage source will be 5 watt. Come for the next question. In this question, we have solved the previous year questions based upon the dot convention and inductor connection. Here also series. So according to dot convention, see, inductor 1 and the inductor 2, they are opposite, because when current enter from here, the dot will be leaving here, and come for 2, it is entering here. So both are in opposite. For positive or additive in nature, both mass and should be either entering or for additive in nature, both mass and should be entering our nature, or both mass and should be leaving in nature. So for this circuit, see here, in inductor 1 the current is leaving, but in inductor 2 the current is entering, so the both are opposite, so it is subtractive in nature. So in this case the mutual inductance will be negative, means minus. See, for the 2 and 3, in figure 2 and 3, listen, current will be entering here, the entering point, the dot is there. For L3 the current here also entering here, so both are same, so it is positive, means additive in nature. Come for the 3, listen, current is entering here, which is the dot is end of the inductor, means end of the inductor, but the dot in L3, in inductor 3, in the dot is starting point. So in L1 it is ending point, in L3 it is starting point. So these both are in opposite. So it is opposite, means subtractive in nature. So the both are in subtractive in nature. So mutual induction between them will be subtractive in nature. So these three are connected in parallel condition. Series condition. So we will add according to that one plus. So see here, L1 plus L2 plus L3. Listen here, 1 and 2 in this figure, 1 and 2 subtractive in nature, because here ending in L1 it is ending point, is L2 it is starting point. So both are opposite. So it will be minus 2, 1, 2. For 2, 3 it will be plus, because here also starting, here also starting. So it will be plus 2, 2, 3. See, for the 1 and 3 the dot is ending point, but in 3 the dot is in starting point. So the both are in opposite. So minus 2, 3, 1. So put the all this value. L1 given 4, 1 to L1, L2, L3, 4 are given 4. So minus 2, M12 is given 2. So 2 into 2 plus 2 here put a, but M23 is given, 1, minus 2, M31 is given also 1. So we will write for this one 4, 12 minus 4 plus 2 minus 2. So these two cancel. So 12 minus 4 is equal to 8 Henry. So 8 micro Henry. Sorry, not micro Henry, 8 Henry only. So 8 Henry. So all this problem are based on the dot convention. When dot are in opposite, means that is subtractive in nature. When dot are in same way, means they are in additive in nature. So according to that one we will add or subtract. So this is the series connection of the inductor. So the total inductance, the terminal point A and B is 8, which is the 8 Henry. This is the figure, and the B is 8 Henry between A and B. This is the figure they have given. Take another the similar way question. They're asking, this is 1 2 3 inductor connected in series, and they are saying from this figure calculate the terminal inductance between A and B, means the equivalent inductance we have calculated from this figure. But see, listen here, from the dot convention, suppose current is entering here, so the dot will be here is starting point for L1. See here, for this is L2, for L2 the dot is ending point. L1, for L1 dot is entering, for L2 it is ending point, so these both are opposite, so it will be negative mutual inductance. For see here, for 2 and 3, so for 2 this is dot is ending point, for 3 also ending point, so the both are the same here, both are ending point, it will be additive in nature. For according to dot convention, when both the dot are same, means either they are ending point or starting point, but the mass turn should be in the same place. In this case we can have additive in nature. When they are on opposite, like consider for L1 and L3, listen, see here, so this dot will be the starting point, but L3 dot is ending point, so the mutual inductance between them is subtractive in nature, because here ending, here starting, so it is opposite. So we will calculate for this problem. According to sign convention, this 1 and 2 they are opposite in dot connection, so it will be subtractive in nature. Subtractive. Again one more thing, 1 and 3 these two are the opposite in nature, so M12 and 31 are subtractive in nature, but M23 is the additive in nature. So L1 is given 4, L2 is given 5, and L3 is given 6. L3 is given 6 Henry, but M12 is given 1, M12 is given 1, M23 is given 2, M31 is given 3 Henry. So we can calculate the total equivalence inductance terminal A and B is equal to L1 plus L2 plus L3 minus, because these two are in opposite, L2, so minus 2 M12 plus the dot additive in nature, so plus 2 M23 minus subtractive in nature, so minus 2 M31, so L1 4 plus 5 plus 6 minus 2 M12 value 1 plus 2 into M23 value 2 minus 2 into M31 value 3. So calculation for 4 5 6 minus 2, this will be 4 minus 6, so all the value we will get 11 Henry. So the equivalent inductance terminal A and B is 11 Henry. So in question number here, question number 28, the option C is the correct answer, which is the 11 Henry. It's the equivalent inductance terminal A and B is the 11 Henry. So option C is the correct answer. In question number 27, they have given that a 10 volt battery and an internal resistance of 1 ohm, which is connected across a non-linear voltage V, and the VI character equation given by 7I is equal to V square plus 2V. They are asking find out the current value. Now listen, this is the 10 volt battery and its internal will be 1 ohm resistance, and this circuit is connected across this non-linear voltage, this non-linear loop whose voltage will be V. This is connected across this one, and the loop equation is given 7I is equal to V square plus 2V. This is the 7I is equal to V square plus 2V. Let's apply here Kirchhoff's voltage law. So 10 minus IR minus V is equal to 0. So 10 minus I is equal to V. Take this one equation 2 and this one equation 1. Putting equation 2 in 1, we are getting 7I is equal to 10 minus I. In terms of V, we are putting 10 minus I square plus 2 10 minus I is. So calculating this part, 7I square minus 29I plus 120. So it will simplify this one. I is equal to 24 or 5. So current will be either 24 ampere or 5 ampere. So the current delivered by the battery is 24 or 5 ampere. So so the current flowing, this value will be 5 or 24 ampere. So this current will be 5 or 24. So here is the current delivered by the battery is 5 ampere. So we are continuing with this video. If you like this video, share, like and subscribe. So it is very motivate for me to make more and more video. Jai Hind.